What makes art human? Are machines capable of creating music? And is it possible to program a computer to make music just like a human would? My name is Tejaswi Gorti, aka Kontejas. I'm an electrical engineer, musician, and sound designer. I've always wondered what the human factor of music was. Your brain is capable of so many things. Everything that you've learned since you're a baby. How to walk, how to talk, how to play an instrument, or solving complex problems. All of these skills are stored up in here. How is it possible you could store so much information in such a small space? Enter the neuron. For everything that we do, a specific set of neurons is fired. And the more we repeat that task, the stronger the connections between those neurons becomes. What if you could program a system exactly like this? Well, you can. It's called an artificial neural network. We tend to think of musical expression and artistic creativity as these mystical things that we can't really explain with science, logic, and reason. This is what gave me the idea to explore the musical creativity of artificial intelligence. The first task was to understand how we create music. What is the simplest way to write a song? Well, you might start with the beat, a chord progression, and then a melody. So let's work backwards. Given a chord progression, one can improvise a melody by messing around with the notes in those chords. The chord progression is usually in the form of long sustained notes, like strings or a pad. I created this Max for Live patch to listen to audio from a chord progression and track the fundamental pitch in real time. The result? An interesting, almost improvised melody that gels with the background chords. The next part was a bit tougher. Now I wanted to use neural networks to come up with beats. Like I mentioned, neural networks are all about correlating input and output, finding patterns, and strengthening the understanding of those patterns through repetition. In my case, I decided to use qualitative and quantitative descriptors to characterize the beats, such as complexity, syncopation, and the musical genre that the beat is associated with. The most tedious part of all of this was generating all the beats and documenting all of these descriptors. Though I used a pretty small dataset to train my neural network, I was quite surprised that the generated rhythms were actually kind of groovy. The last missing link was a neural network to generate chord progressions. This was much more challenging. In this case, the descriptors would be emotion and mood, as well as the complexity of the progression, i.e. how many notes are used. Initially, I used about 50 different chord progressions to train my system, and things started sounding very strange and dissonant, like this. With a few more tweaks to my system and expanding my training dataset to include more R&B style chord progressions, the result was a lot more jazzy. But now it was time for the artistic side of things. How could I take this generative stuff and make it accessible to the listener? The more I played around with the neural network output, I found myself essentially remixing what the computer came up with. Within Ableton, I also decided to include other generative techniques, such as randomized follow actions, white noise-based LFOs, and the Max for Live device randomizer. Unlike the music I usually make, I had to hold myself back from overly manipulating the computer's output. It was a fine balance between making the music relatable and retaining its generative aspect. Thus is born Neuroplastik, an 8-track album where I've used computer generative techniques as a creative catalyst, with 4 tracks purely computer generated and 4 of my remix renditions of them. The album is centered around the concept of artistically coexisting with technology.